9.4 goes over inverses of functions. The first part of this lesson that we are going to be looking at is to determine whether each function is invertible. If it is, your y values do not repeat. So you want to look at your y values from each of the given ordered pairs for the function that's given to you for that problem. If any of those y values repeat, the inverse is not a function. If they don't repeat, then the inverse is a function. In order to give the inverse of the function, the only thing you're doing is switching the x and the y values. So your y value will become the x value, your x value will become the y value from that ordered pair. If we look at example 1a, we're determining whether each function is invertible, and if so, finding the inverse. For a, we have f is equal to the ordered pairs, or the set of the ordered pairs, negative 2, 4, 2, 4, and 3, 9. Look at those y values. You do have 2 4s here, so the inverse is not a function for this one. For example B, we're given G is equal to the set of ordered pairs of 2 1/2, 5 1/5, and 7 1/7. If you look at all of your y values here, they do not repeat, so the inverse for this one is a function. In order to give the inverse, just switch the x and y value for each of the ordered pairs. So instead of the first ordered pair being 2 1/2, it's going to be 1/2, 2. The second is going to be 1/5, 5. And the last is going to be 1/7, 7. To write the inverse, you would do g to the power of negative 1 of x is equal to. For example C, we have h is equal to the set of ordered pairs 3, 5, and 7, 9. Once again, if you look at your y values here, they do not repeat, so the inverse is a function. You can give h to the negative 1 of x is equal to the set of ordered pairs 5, 3, and 9, 7. The next part of this lesson is something that you've already seen before. We are using the horizontal line test to tell whether or not the inverse is a function. If you draw a horizontal line through the function that's graphed on your coordinate plane, and that horizontal line intersects more than once, the inverse is not a function. So if we look at example 2a, we have this parabola that's on this graph. If we drew a horizontal line through it, it would intersect in more than one place, so the inverse is not a function. For example B, if we draw that horizontal line through that function, it would intersect only one time. So for this one, the inverse is a function. So the next part in your lesson, you are determining whether the functions of f and g are inverses of one another. When you do this, you can pick any number to plug in for x in f of x. Whatever you get for your answer for that function, you will then plug in for x in g of x and simplify. When you get your answer for g of x, if it was the first number you plugged in for f of x, the two are functions. So if we look at example 3a, we have f of x is equal to 3x and g of x is equal to x divided by 3. If I, let's say, pick 2 as my x, I'm going to take 2, x is equal to 2, and plug it in for the f of x. So I'm going to do f of 2 is equal to 3 times 2, which is 6. So f of 2 is equal to 6. Whatever I get from that, I'm then going to plug in for x and g of x. So now, since I got 6 for f of 2, I'm going to do g of 6 and plug in the 6 for x in g of x. So it's going to give me 6 over 3, which gives me g of 6 is equal to 2. This just means that you have ordered pairs of 2, 6 for the first function and 6, 2 for the second function. Because your x and y values switched for these, they are inverses. So we can say that g of x is the inverse for f of x. For example B, we have f of x is equal to 2x minus 1, and g of x is equal to 1/2 x plus 1. So if I choose to do f of 2, I would have 2 times 2 minus 1. The 2 times 2 is 4, minus 1 gives us f of 2 is equal to 3. So that's the ordered pair 2, 3. I got the 3 for my y value for that f of 2. So plug in the 3 into g of x. So we're going to do g of 3 now. So we're going to have 1/2 times 3 plus 1. The 1/2 times 3 is 3 over 2 plus 1. The 1 is the same thing as 2 over 2, so that would be 3 over 2 plus 2 over 2, which gives us 5 over 2. So g of 3 is 5 over 2. This is the ordered pair 3, 5 over 2. If we took the first ordered pair and the second ordered pair, did your x and y values just switch? They did not, so they are not inverses of one another. So in order for them to be inverses, your x has to change to be your y, and your y has to change to be your x in the second function. For example C, we have f of x is equal to x squared, and g of x is equal to the square root of x. Again, if I choose 2, and I do f of 2, that's going to give me 2 squared, which is f of 2 is equal to 4. So now I'm going to do g of 4, which gives me the square root of 4. The square root of 4 is 2, so g of 4 is equal to 2. This gives me an ordered pair for my function f of 2, 4, and an ordered pair for my function g of 4, 2. The 2, 4 and the 4, 2, I just switched the x and the y values, so these two are inverses. The last part of your lesson does go over finding the inverse of a function. So you're going to be given a specific function and told to find the inverse of it. In order to find the inverse of that function, you are going to replace the f of x, the g of x, the h of x, the anything of x to be y. Then you are going to switch your x and your y. So your x will be equal to, your equation will be equal to x. Then you're going to resolve the equation for y and replace the y with f to the negative 1 of x, g to the negative 1 of x, h to the negative 1 of x. That to the negative 1, so the power of negative 1 of x, represents that the function that you are given is your inverse. So if we look at example 4, we're just finding the inverse of each function. For a, we have h of x is equal to 2x minus 1. We're going to switch out that h of x for y. Then we're going to switch x and y. So this is going to be x is equal to 2y minus 1. And we're going to resolve this equation for y. So we're going to move the 1 over by adding it to both sides. We have x plus 1 is equal to 2y. From here, we would just divide each side by the 2, and we get y is equal to 1/2 x plus 1/2. This, however, is not our answer because it doesn't represent that this is the inverse. So we had an h to begin with, so we're going to have h to the negative 1 of x is equal to 1/2 x plus 1/2. For example, B, we have f of x is equal to 1/2 x plus 3. So again, we're going to change the f of x to be y. So it's going to be y is equal to 1/2 x plus 3. Then we're going to switch x and y. So we have x is equal to 1/2 y plus 3. Solve your equation for y now. Move the 3 over by subtracting it from each side. We have 1/2 y is equal to x minus 3. From here, you're going to divide each side by that 1/2 to get y by itself, or multiply by the reciprocal. The reciprocal of that is 2. So we're going to cancel out the 2 times 1/2 next to the y and just have y. And then distribute the 2 into the set of parentheses, so we have 2x minus 6. Again, we're working with inverses. We started with f, so this is going to be f to the negative 1 of x is equal to 2x minus 6. For example C, we have f of x is equal to x plus 1 over x minus 3. So again, we're going to change the f of x to be y. So we have y is equal to x plus 1 over x minus 3. Next, we're going to switch x and y. We have more than one x, so wherever there is an x, it's going to become a y, and wherever there's a y, it's going to become an x. So this turns into x is equal to y plus 1 over y minus 3. We want to get rid of the fraction, so we are going to take the y minus 3 and multiply it to each side. From here, we're going to have x times y minus 3 is equal to y plus 1. Now, we're going to divide each side by the x, and this is going to become y minus 3 is equal to y over x plus 1 over x. You want your y values to be on the same side. You want your constants to be on the side with x. So we do have a y over x. I am going to first move the 3 over by adding it to both sides. So we have y is equal to y over x plus 1 over x plus 3. From here, that y over x you want on the other side. So subtract it from each side. This gives us y minus y over x is equal to 1 over x plus 3. You don't have like denominators on that left side, so put it over 1, multiply the top and the bottom by x, so you have x, y minus y over x is equal to 1 over x plus 3. From here, you can factor out a y from your numerator, and you're going to have y times x minus 1 over x is equal to 1 over x plus 3. Keep going, multiply each side by x. You can distribute that in. So you're going to have y times x minus 1 is equal to x over x plus 3x. That x over x becomes 1. So we're just going to take that out, put a 1 in there. And then from here, we're going to divide each side by that x minus 1. So we have y, I'm going to put this up here, is equal to 1 plus 3x, which is the same as 3x plus 1 over x minus 1. Again, we started with f. So this is going to be f to the negative 1 of x is equal to 3x plus 1 over x minus 1. For example D, we have g of x is equal to 3x plus 4 all over 5. For this one, we're going to change the g of x to be y. Then we're going to switch x and y. So we have x is equal to 3y plus 4 all over 5. We're going to solve this equation for y. First, we're going to multiply each side by the 5. So we have 5x is equal to 3y plus 4. From here, we're going to subtract 4 from each side. We have 3y is equal to 5x minus 4. And then we're just going to divide each side by the 3. So we have y is equal to 5/3 x minus 4/3. We started with g, so we're going to have g to the negative 1 of x is equal to 5/3 x minus 4/3.